Là, ça module pas, hein, on est d'accord.
we did like this. And with two interface, human-machine interface, we can do an interaction between two machine-to-machine interaction, but by two humans. And in fact, the interaction was between Mano and me directly to control the show. So if you have no question, maybe we are going to set down the stage. Yeah. Okay. Yeah, the humanoid robot is named Poppy. Is a humanoid robot designed by Ineria in Bordeaux, who did this robot to learn artificial intelligence, how a robot can learn to walk. It's a long-term research, but this robot was designed for this. But this is the only robot in the world who has a back completely articulated. He has 5 degrees of freedom in the back, which is very, very powerful for the choreographer to make some choreography. As you saw when he gets up, he used his hips to make something more fluid. And in fact, we decided to use this robot to build this because this robot is completely open source. Apart the motors are not open source. And after we built 2 of these to make a show with 3 now. This is the other robot. 3 now. Now is very powerful because it can walk and can displace on stage to take the space. Yeah.
So you spoke about the head motion in particular, but for the rest, for the legs, the arms, and so on, do you have like predefined primitives or so like predefined motion that you can trigger? Or
yeah, it's kind of choreographies. There is a list of what, as we know, we call this. It's like a cartoon. In fact, we have keys. It's the photos, and after inside the head of the robot, there is an algorithm which do interpolation, polynomial interpolation between all the poses. And when we want to program the robot, we do not set the angles of each articulation, but we take the robot like if it was in glue, and we block. We say top, and he takes the photo, top, 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 and we do all the choreography like this. We have all the key poses, and after we walk between the poses, like in cartoon, we can do some animation more fluid with effect, with like in a Disney cartoon, in fact. We use all the Disney cartoon techniques to make after the show.
How much time it takes to generate this motion?
For example, for the motion to when it gets up, it took us half a week. Half a week after we did another animation with 2 robots. The 2 robots were doing love. It took 1 week and a half. Because there are 2 robots to synchronize, and after they made love, it's very, very impressive. And
you have a small robot after that?
Yeah, maybe I hope. Okay, maybe see. Yeah, I think it's time. Thank you very much for audition.
Thanks a lot, Thomas. May I here? On your left. May I suggest that you keep performing until all the officials are arrived? Is it okay for you? Thanks a lot. And thank you for being here.
Yeah. So in fact, I have to speak, but yeah, I can speak a lot about the second robot. I don't know if we can say so. What is a robot? But about the drones, we are working about this. We are working with pilots because we wanted to have autonomous drone. This is one of the subjects we want to study. We contact a lot of laboratory to study about how to make the drone autonomous. And we did set up here half an hour before. We want to do this with the autonomous drone with the same time of setup, and it's very difficult because most of the time we have to set up some cameras or to have some UWB dispositive to make the triangulation of the drones. So we are going to do some research about this. It's very difficult because or it's too much expensive because of the dispositive, or we have to hire 3 pilots. We decided to hire 3 pilots because it's very funny. You have the choreographer who does okay, top swarm. The choreographer loves this. He can control directly the drones without any issue about informatics. Only radio control, and it's okay. So we can design some of choreographies, and the show, the first one will be in June in 2018 in Marseille, in the Ballet National de Marseille, which is a national, very important national dance room, very famous. And we have to train. But there won't be the humanoid robot. There will be 3 dancers, 3 grid dancers of ballet also, which are doing this. And the show will be in 2 parts. The first part will be with drones, and the second part will be with 1 drones filming in Beirut, in Lebanon, and always be streamed live in France directly. And we will see the video of the streaming live in the second part of the show. And in Lebanon, there will be some refugees, Syrian refugees, who will dance their traditional dances, and all will be designed, all will be filmed with a drone, which will fly and very high in Beirut. So that's another challenge about streaming live, because when you make a show, you don't have to have a Skype issue, or it doesn't work. What a pity. No, when we will be the show, we want to monitor all the line of internet between the Beirut and here, and all will be okay when we start do the projection of the streaming live. So there is a big challenge about interface, how to manage an internet connection with all the data we want. So it's a good challenge also, a good challenge. Yeah, in fact, we are an association in Toulouse who take care about artists and robotics. We want to make something very powerful and very complicated things as robot drones to put on stage, and we are now working about artificial intelligence also. We want to make a machine which is intelligent and which is alive. Call this project the Alive Machine. This is another project. How to make a machine alive. That's another question about human-machine interaction, which is we want to mimic life. In fact, how we can mimic life if you want. So maybe you have some question. Yeah. Ça va me prendre 5 minutes pour reprendre. Donc, okay.
Yes. For the robot, what are your objectives on imitating life? What do you call being alive?
About the humanoid robot? In fact, for the humanoid robot, the challenge was there are children on stage and the robots. They have the same size. The challenge was to make the robot more human than the children. So we wanted to, this was to make a caricature, to make some provocative images, of course. And it was very funny because we wanted to make some exaggeration about the gesture, to make like Mickey, and to make something more human, more smooth. And on the other side, the children were doing something more sculpted. And the objective was this, to make something more smooth about the robot, something more quiet, more and very slow. All the show is very slow, so that the audience can see every gesture. So it was that's the objective, and we are working more. We are working like a puppeteer, in fact. That's the objective. This is the main. This is the main source of inspiration, in fact, about our work. It's the puppeteer. We read a lot of old books about how to make puppets more alive. There is a lot of bibliography about puppetry and how to make good gesture, and a lot of things to learn. In robotics, we don't ever use such kinds of trajectory. In fact, it's very different. It's not very efficient like a trajectory. Maybe we can optimize the trajectory so that it's more alive, but it's very difficult to know what to optimize, in fact.
Back to Puppy, as we are here a bit to hear about FabLabs. Did you make your own Puppy within a FabLab, and how was it?
Yeah, no, Puppy is, I didn't do in FabLab because it's a technology a bit special. It's laser SLS 3D printing to do all the parts. And we did not use the 3D printer here because it's not enough resistance for mechanics. But after we have to turn the screws. There are 500 screws, and I have 2 robots like this. So when you have a show, you have to verify all the screws, all the connectors. It's a long time, and in fact, all is inspired by all the technology we use in FabLab. In fact, it's 3D printing, and after all the programming is done in Python. Inside the head there is a Raspberry Pi. We use all the technologies about FabLab, in fact. Maybe you can set on back and he's still alive. Okay, maybe you can turn and do all the... It's not very sexy. No. As you see, there is a connector left. I have to just plug it. In fact, most of the time I put some glue, hot glue, on the connector. But here, it just broke. Okay, you can get up. You see the work of the dancers who did the choreography. This is not the robotician who did this. So that's it. As you see, he's breathing so that he can be alive. Okay. Maybe I can... it's okay? Okay, I will sit down.